Morning, guys. Today we're gonna be talking about thin lenses. As I told you yesterday, I'm going to show you this procedure. Now, for sample problem B, we have an object that is placed 30 centimeters in front of a converging lens. So, converging lens, I have this data, okay, object placed, P, 30 centimeters. So, when my object is placed in front, I have to take a look to my sign conventions. As you can see, is in front, real object, we have positive symbol. So, this you're going to consider it to be positive. Now, for diverging lens, we have this object to be placed 12.5 centimeters in front of diverging lens. So let's see, diverging lens, okay. So it says, the sign convention, that when the object is placed in the back, we're going to have a negative symbol. So again, this one is going to consider to be positive. Now, both lenses have a focal length of 10 centimeters. So focal length, 10 centimeter, focal length, 10 centimeters. Now, let's read about the sign convention. It says that for converging lens, the focal is positive, but for diverging lens, the focal is negative. The symbols, I'm taking this from the sign convention table that is on your book, okay? So what am I looking for? It says for both cases, find the image distance. So I'm looking for Q in both cases. And then magnification. I have no idea what the magnification is, so I'll be using the formula that we have in our textbook. This one you probably don't see it. Okay, now it looks better. Okie dokies. So we're gonna make use of our thin lenses equation, that is basically the same that we used to use for lenses, for mirrors. So to find Q, it's 1 over Q equals 1 over F minus 1 over P. So this is equal to 1 over 10 plus minus 1 over 30. This gives me a total of, let's see, 1 over 10 minus 1 over 30. Okay, 1 over Q equals 1 over 15. After this, remember that I told you that we should raise it to a negative first power, like that. Therefore, you will have your Q equals to 15 centimeters. Okay. As it is positive, this image, as it is positive, we're going to consider to be back and real image. Now, for divergent lens, this changes, okay? Okay, the formula is not going to change. It's 1 over Q equals 1 over F minus 1 over P. But remember, focal, in this case, is going to be negative. So this will be 1 over negative 10 minus 1 over 12.5. This gives me, let's see, 1 over negative 10 minus 1 over 12.5. Okay, it says 1 over Q equals negative 0.18. So from this moment, I raise it to a negative first power, both sides of the formula. So I will have Q equals negative 5.56 centimeters. This image is, as it is negative, when the image here, Q, is negative, we have that is in front and virtual. The only possible image that a diverging lens could give us. So both of them are our answers, okay? But we're missing something. We're missing something. We're missing magnification. So easy. Magnification is just I'm going to separate this page. Wait. So for magnification, now that I already spot my patient too, for magnification we have the same formula that we used to use before. I'm going to do it here in a single space. Negative Q over P. Negative Q over P. So this will give me negative 15 over 30, negative 0.5 is the magnification here, and the magnification here is negative 5.56 divided by 12.5, and this gives me, let's see, negative and negative will be positive, so 5.55 divided by 12.5 gives me a magnification of 0.44 magnification. Okay, what does it mean? A magnification less than 1 means that the object is being reduced, okay? Is reduced, both of them. Now, the negative means that is inverted, and this positive means that is upright. That's what it means. Okay, we're gonna see this into the ray diagram that we will do for both parts. Now I'm gonna draw here the ray diagrams. As you can see, I have already placed my data for converging and for diverging lens. It is coming from the procedure that we used to have here, okay? Everything that I have there, it's coming from this page. Now, let's see. For converging lens, we have an object that is placed in front. The object is placed 30 centimeters and the focal length is 10. So that means that the object is placed outside twice the focal length. So it says the image is going to be real and smaller. So magnification is less than 1, so yes, the image is smaller and it's real as we just got here. So we're gonna make use of number 2 because it's the only situation where my object is placed outside twice the focal length, okay? Because 30 is greater than twice the focal length, that is 20. So I'll be using number 2, the configuration number 2. Let's see. Okay, because of my drawing, I will say that I have my lens right here, okay, right here. Here I will have my lens. Okay, now from the center of my lens to my focal length I have 10 centimeters. I will be using 1 inch. So I'm going to place my focal point right there. In both sides, remember that in this type of ray diagram we have the focal length in both sides of the converging lens or any lens. So the distance that I have here is just 10 centimeters in both sides. Now, my object P is placed 30 centimeters away, so I'm going to count 1, 2, 3, 10, 20, 30. My object is placed here at P. Now, I don't know, the object is not specified, so I'm going to just draw an arrow like that to represent my object. Now, what am I gonna do? I will follow the configuration of my ray diagrams, okay? The one that I have right here. My rays are coming from the top of my object. The first ray, okay, I'm using green. The top of my object, farther to the surface, then it passes through the focal point that is there. Then from the top of my object through the center, I better do this through my focal. So passes through the focal point, comes from my object, focal point, touch my lens, and then straight parallel to the surface until it reaches the other line. And here, from my top of my object to the intersection. So my object, my image, is gonna be forming right here. Now, according to the magnification, it says that it's upside down, so my image will be formed like this, upside down, just like we have right here. Now for my diverging object, we finished. Okay, that's it. I had a mistake and I had to correct it. I did it. Now for my diverging lens, not object lens, I'm gonna be using this for this table. Okay, so I'm gonna be drawing the axis right now. I'm going to stop the video. Okay, I just did this configuration over here. So, okay, I need to locate my focal point. It says that it's 12.5 centimeters. What I can do, because 12.5 is just too much for me, it doesn't basically fit here, so I will divide by 2. That my scale will be 2 to 1, okay, 2 to 1. So that means that the line that I will be measuring is going to be 12.5 divided by 2 is going to give me 6.25. P is going to be at 6.25. So I'm going to be measuring 6.3, because from this point, from the middle, okay, 6.3, that is right there. So here in this point is my P, my object P. Okay, so I just place my object, same arrow that I did in the exercise above. So I just need to follow the rays. Now, it says that my first ray, I'm gonna do these rays in red. No, in blue, sorry. Because my object is red. Okay, so my first comes here. I forgot my focal length. It says it's 10 centimeters, so I'm going to measure 5. My focal length is, my focal point is there, is here. Okay, I kind of forgot. So, the first ray touches my, remember that we measured this till the middle point of my lens. So it touches my middle point of my lens, and then it is projected until the focal, okay, until the focal point. Now, as it is just a projection, we're gonna do a dash line, and then the ray diverge in the back of my mirror like that. That is my first ray. my second ray, I need to measure the same in the other side to locate my focal point. It's here. Okay, my second ray comes from the top of my object here to the other focal point. So here it comes like this. And then it's projected to the focal point. But the ray in this point is measured, then it is refracted like this, horizontally. But it is projected here. And therefore, my third ray, as you can see here, we have the converging point. So we're going to pass the last ray through that point over there, like that. So my image is going to be formed there. As you can see, it is smaller than the object, but it's upright, just like that. So this will be my ray diagram for my diverging lens, and this will be my ray diagram for my converging lens. Guys, I hope you have understood this topic. See you next class.